All right, problem 46 on page 198 is a sister to your assigned problem 47. This is finding asymptotes of rational functions. That's the nature of all of the problems on page 198 from 45 to 56. And it's, I'd encourage you to do enough of those problems so you really get it. What the author is having you develop some skills with is the summary of the information that's given on page 194 in the yellow box. It's entitled Finding a Horizontal or Oblique Asymptote of a Rational Function. And there's an entire set of rules there in that box, and they involve they involve comparison of the degree of the numerator, the polynomial in the numerator, to the degree of the polynomial in the denominator. And in fact, I'm going to just read the very first rule, which says that if n, the degree up here, which is 1, is less than m, the degree down here, the polynomial in the denominator, then the line y equals 0 is a horizontal asymptote. So that's not the case here, okay? But these set of rules are what you use in order to determine what type of asymptote that you're dealing with. So in this particular case, the degree of the top is 1. Let me write this down. In this case, the degree of the top is 1. The degree of the bottom is 1. And for that prescription, in this case, what results is a horizontal asymptote and that's y is equal to, in this case, I'm going to write it as y equals a constant, but the constant is the ratio of the coefficients of the leading terms. So the way I like to show that is, let's rewrite r sub x, and the way I'm going to rewrite it is I'm going to divide the top and bottom, every term, by x, and I'm going to get 3 plus y over x on the top, and I'm going to get 1 minus 6 over x on the bottom. Okay, and then I'm going to ask what happens when x gets very large, because finding these oblique and horizontal asymptotes is about finding in behavior, the behavior for large values of the absolute value of x. That's what it's about. So I'm going to imagine that x gets very large, and I'm going to find that as x gets very large, the value 5 over x is going to get very small. For x large enough, 5 over x is going to get very, very small relative to 3. And in the same way, as x gets very, very large, 6 over x is going to get very small relative to 1. And so what we can say is that in the limit, as the absolute value of x goes to infinity, that in this limit, r sub x begins to look like 3 all over 1 equals 3. And that then shows that the horizontal asymptote is y is equal to 3. All right, so we've got a couple of other problems here that we'll take on that are associated with finding asymptotes and make use of these rules on page 194, so stay tuned.